The goal of our project was to create a boat that autonomously tracks another boat using an IR signal. As a group, we noticed that there are autonomous land vehicles and autonomous air vehicles, but water vehicles were lacking. Our motivation for this project was to spark that innovation in the field of autonomous aquatic transportation. This is a simple diagram of the two boats. At the top, we have the autonomous boat with its multiple sensors and Raspberry Pi board that reads those sensors and makes the decisions to drive the motors. At the bottom, we see the simple lead boat, with an array of IR LEDs that are pulsed at a specific frequency to allow our system to work in a daytime environment. Here's a look inside Boaty McBoatface. Here you can see the 4 encased sensors on the 4 sides of the boat. These sensors feed data into the Raspberry Pi, seen here. In the rear of the boat, you can see the 2 motors that the Raspberry Pi drives to provide movement. Each of the 4 boxes you saw on Boaty is a water-resistant clear box containing an IR detector circuit centered around the TSSP58P38 sensor. We selected this sensor because of its capabilities to filter for and demodulate a 38 kHz signal, removing a step that would require significant software overhead. You can find these sensors used in all sorts of electronics that use the 38 kHz modulation scheme, such as TVs and DVD players. To pulse the IR LEDs at 38 kHz, we are using an ATmega32 microcontroller to control the array of LEDs, pulsing them on for 120 milliseconds at 38 kHz and off for 380 milliseconds. Here is a demonstration of the LED array on the lead boat. It is a little hard to see, but the LEDs are mounted in a water-resistant box on top of the boat. To the naked eye, the LEDs seem to be off because our eyes cannot see infrared light, but with a camera it is easily visible. You can see that the lights are pulsing on for 120 milliseconds and off for 380 milliseconds. Here you can see the circuit diagram for Boaty. It includes the 4 IR sensors along with all the electronics connected to the Raspberry Pi. The core of our boat control algorithm is a PID loop that takes in sensor data seen on the right and calculates an error value, then adjusts the motors according to that error value. Unfortunately, due to multiple roadblocks involving our sensors in the beginning of the quarter, we were forced to delay the algorithm development part of our project until the later part of the quarter, and were not able to produce a fully working product. The boat in its current state reads sensor data properly, but because we need water to test the boat, we were not able to quickly debug, as each test requires setting up the boat and then moving it into water and moving it back out of the water to read the data. Given a few more weeks, we would be able to further refine the algorithm and have a working product. Here is a video demonstrating the behavior of Boaty in its current state. Here you can see the smaller lead boat. Boaty, the larger boat, should be following the lead boat, but the behavior we see from data collected is that the algorithm corrects too quickly, and because of the momentum of the boat, we do not have enough time for the boat to correct itself before it spins in another circle. Some ideas we had to correct this behavior were to pulse the motors at a lower rate or even shutting them off completely in certain situations to allow for slower movement.